My name is Jeff Regan, software engineer at Google. I've been there for about a little over 10 years, and I've been working on Kubernetes open source stuff for about a year and a half. And today I'm going to talk about configuration customization in Kubernetes. This is a spreadsheet which you're not meant to be able to read, and this is actually only a section of the spreadsheet. This is maintained by Brian Grant, who is one of the founders of Kubernetes, and he's a principal engineer at Google. And he took it on himself to try to collect all of the tools that were being used to configure Kubernetes. He's been building this up over the last couple of years, and it's up to about 60 now. I'm not sure if he's still actively maintaining it. But it's interesting that there's this many alternatives to try to do something which ostensibly maybe isn't so complex. So why is that? If you take a look at this list, you're going to see all these different things have features that are part of different categories. So one of the categories would be, for example, just trying to describe a cluster configuration as an application. So you've got a maintainer, you've got a description of what it is. It's the kind of things you'd see if you were looking at your mobile phone app. And then there's notions of app discovery. How do I search for things? How do I browse for things? What is available? How do I download it? Like a store, right? There's package management features, like bundling things, finding the dependencies, and so on. There's also things that some of these tools offer diagnostics and cluster dashboard kinds of things, like what apps am I running? What is their status? Are they all healthy? Lifecycle management. Rollouts, rollbacks, upgrades, all these kinds of things that are tricky to do. And then another thing is customization, which means given some example of how to do things, how do I change it and tweak it in such a way that I can do what I want to do, but then maybe maintain the original content. So that's what I'm going to talk about today, just that. And we have a tool that does this. It's called Kustomize. And it closes several old kubectl issues, and it's sponsored by the SIG CLI group of Kubernetes, and it's we've got a KEP you can read, and you can find out what bugs it closes, actually, what issues it closes. So this is how you use it. Hello world in this example is a directory. You just say Kustomize build and then the directory name, and that's going to spit out a bunch of YAML to stand it out, and you can pipe that right into kubectl apply and put the hyphen there so that it reads from standard in. What's in that directory? So this directory has 3 files I'm sure anybody who uses Kubernetes would recognize: a config map, a deployment, and a service, right? The deployment's getting its parameters from the config map. The service is the load balancer to say that allows you to hit any one of the replicas. And the new thing here is this customization file. It is also YAML, and you can just drop it in the directory. Kubectl apply will read this directory without the customization file and just run stuff on Kubernetes. With it present, it'll currently give you an error saying, I don't know what that is, but I'll go ahead and send the config map and the deployment and so forth off to your cluster. So this is a toy example showing what that customization file looks like. There's 2 things here in the customization files in the middle. It's got a resources stanza, which is specifying a file name, in this case service.yaml. And the text for that is on the left. You've got just a service. Anybody who's ever used Kubernetes will recognize this thing as a standard thing you're going to use in almost anything. In this case, it's got a name, WordPress. So every Kubernetes object has a group, version, kind, and name. That's how you distinguish the different objects that are in Kubernetes. So Kubernetes is a big sea of objects, right? So one of the things you often want to do when you're customizing something is change its name. So this lets you add the prefix demo hyphen to the name of everything that you're going to send out to your cluster. You run Kustomize build, and standard out, you're going to see the name change. You're going to just see WordPress become demo hyphen WordPress. This is kind of a trivial example, right? It's a little bit contrived because you could also just VI, edit the file, and do the same thing, right? Let's dig a little deeper here. So I'm making the point that customization files have 2 things in them generally: operands and operations. Okay? And the way they work is operands come in, they get operated on, right? And that creates a bunch of YAML stream that goes out to your cluster. And in the specific case here, we've got one of the operations is add a name prefix. And you've got operands that might be all the YAML files you've got in the directory. And that's going to go out to your cluster. And the other thing you can do is you can take the output of a customization and use it as input to the customization. So you can get this recursion thing going. That's handy at 2 levels deep. That can be pretty handy, and it's important for doing things like overlays, which we'll cover in a second. So just to reemphasize, Kustomize reads plain Kubernetes YAML. So you can kubectl apply the YAML without using Kustomize, and just dropping a customization YAML file into your collection of resources allows you to start customizing them. And you don't need anything special to change in your raw resource files. Right? So many things you might want to customize: namespaces, names, labels, annotations. Your container, you're going to want to change the image tag as you roll out new versions, but maybe all you want to do is change the image tag and leave everything else alone. You're going to want to, as you go to different, your production cluster and your staging, you're going to want to change your number of replicas, your CPU, your memory allocations, and so forth. Kustomize lets you do this in a sort of straightforward fashion. So here is all of the source code boiled down to a couple of lines. This is how Kustomize works. The first thing it does when you run Kustomize build is it loads its internal notion of what Kubernetes objects are. So Kubernetes objects all have a meta type field in it that's got a name in it. There's places where you can stick labels, there's places where you can stick annotations and selectors and so on. All that stuff is loaded. We initially had it hard-coded in. We've modified that to accommodate CRDs, so we can read all this stuff in from files. Second thing, step 2, read the customization file from your target. Step 3, customize all the bases specified in that customization file. I'll talk about this more in a second. This is recursion step. Step 4, load or generate the resources that are specified in the customization file. So here's where you load your deployment.yaml, your service.yaml, your config map.yaml, or you may generate the config map by reading some local file that's got like your name value pairs in a simple text file. Now, you're going to merge all those resources together in this big sea of objects, and then you're going to apply all the operations that are specified in that target, in that customization file. Here's where you're going to modify the names, you're going to add the labels, add the annotations, apply patches, and so on. Now, the last step is important, fixing all the name references. So you've modified all the names, and you have deployments that are referring to config maps, and they need to find them so they can get their parameters out of them. And that's something we have to go and basically fix all the links. And then the last step is emit the YAML. So let's run through some use cases for Kustomize. A very common thing many people want to do is they want to take a set of images and run them in 3 or more environments. Typically, we call them production, staging, and development. So production is where you're going to hit, your 10,000 queries per second from the wild internet. So you're going to want to have a lot of replicas, you're going to have a lot of CPU, and so forth, and some known image. Staging is a place where you're going to run your next candidate for production. You're going to maybe give it 1% of their traffic or 0.1% of your traffic, and you're going to it's going to be running a new image. It's going to be running a new image tag, your candidate for running out in production. And then there's going to be development where you're going to be doing your QA. Maybe you deploy hourly builds to QA. Maybe you do it once a day. Whatever, it's a different image, and it also requires fewer resources. So with Kustomize, you set up your base. Your base is all the common elements. That's on the left. This is a customization file that does little more than just act as a manifest, listing out the different resources you need. And then you've got 3 customizations, because I'm talking about 3 variants now. I'm talking about production, staging, and development. And all I've got listed here is I've changed the name prefix that's going to be applied to the resources, and I've also listed that in staging, I'm going to use a different tag, and in production, I'm going to use a specific tag, like I want to use exactly this version because I'm going to comply with Sarbanes-Oxley and so forth. And each one of these files is referring to a base. You see this dot, dot, slash, dot, dot, base thing. And this is going to come from this recommended file layout, or this file layout that I'm using. So here's the layout on the right. Let me talk about the base a little bit first. So I can just specify, remember the argument to Kustomize is a directory. So I can say Kustomize build WordPress / base. WordPress is just the name of an application. This customization file that you find in the base directory has 2 resources listed, a deployment and a service. And it also has a little env.txt file that has a bunch of name value pairs in there for that the deployment's going to need to use to, say, edit the arguments on the command lines that are used in the container. Service is nothing weird going on there. Deployment's nothing unusual going on there. And I could just go ahead and I could deploy that to my cluster. All that YAML just works. I could just do kubectl apply and not even use Kustomize here. Now it gets more interesting. I'm going to introduce an overlay. That's going to be in a sibling directory. So overlays is a sibling directly to base. And there's a customization file in there. That customization file has a set of bases, and they're pointing to, it's specifying a base that's up a couple of steps and down. So that's saying go read that customization, get all the resources out of that, and then we're going to apply 2 patches. One is going to increase the replica count, and one is going to increase the CPU count. I could have combined those in one thing, but maybe I want to use them individually in mix-ins. Say maybe I want to use that same CPU count file to modify some other production environment, and maybe, so I keep these things separate and I can mix them. So mix-ins is a useful thing here. So how do I deploy production? I just do that. I just say Kustomize build WordPress overlays production and pipe that into kubectl apply. Same with staging. So you get the drift here. For every variant, you're going to want to have a different customization file. And they share common stuff in the base. So again, the customization file is a collection of operands and operations. So operands are things like resources. Then there's generated resources, so you can generate config maps. This is kind of a convenience thing that Kustomize gives you. CRDs, what are they? Custom resource definitions. All that does is it can read these things, and that expands the list of resources that Kustomize is able to understand and modify. And then bases, as we talked about, that's just another, that's a thing that's already been customized, so that's the nesting. Operations, add a name prefix, add labels, add annotations, perform patches, and then there's some more exotic things like variable substitution, which we'll talk about in a second. We'll talk about right now. So here, the customization file has a vars stanza. Now, what is this doing? It's giving a name, in this case, MySQL. Let me tell you the big picture here. You've got WordPress, which is a content serving system, and it needs a database on the back end. And when you fire up WordPress, say, from the command line, it needs to know where MySQL is. It needs to have some sort of name that it can use to find out where its database is, identifying information. So how do you get that to happen in your pod template spec in your deployment where you're running WordPress? You need to know where WordPress is, but the whole thing about Kubernetes is it can put it anywhere, right? And you have to address it by name. So what I'm saying on the left here in the customization file is saying, I'm going to define a variable, and that variable is going to take on the value of what is in the metadata.name field of the service called MySQL. Kind and version are specified too. And then in your patch, in this patch, it's going to, you see MySQL service it sort of appears like a shell variable, and that gets replaced in standard out, and you can see what's going to come out the other side. You're going to see the names that are computed at customization time. This is not runtime. This is just all text processing. The names that are computed at customization time appear in the little container command curl, and also it appears down in the the name value stanza, so you can actually set environment variables that will then be used in the container. Here's another use case. Some folks, certainly we do at Google, and some of the folks we work with like to maintain different sets of properties that are used for a common purpose. So an example might be all the long properties you need to run a service. And then some properties that are special, that are maybe maintained in a special place, like a database, personal information, whatever, database passwords and whatnot. That might actually be controlled by a DevOps team. That might be controlled in a special database somewhere. And you want to combine these things in the cluster. So in the case, we have a base. The base is specifying, let's make a config map using these common properties, color blue, height 10 meters. And then in our production, we're going to have an overlay that's going to merge into that same config map, which is then used by one of our deployments. It's going to merge in this password stuff. And that's how you achieve this. You specify in your patch, say, go get this config map, which is being created in the base, and go ahead and merge in the content of this file. That goes to production. Staging might use a different set. Development, they don't need access to the real passwords. That'll use some passwords that are associated with some sort of development database. And that gets spit out to standard out. Now, there's quite a lot going on here in the name of this config map. It's prefixed with prod because we're going out to production. It's got the original name mycmap that appears in the middle. That's specified way down in the base. And then there's this hash. There's a suffix to the name that looks like a hash because it's a hash of the content of the config map. That hash is important. If you go and edit the value, any of the values in common properties or secret properties, it's going to change the value of the hash. And when that goes out to production, the deployment will also point to that new hash, and it will know it needs to cycle. It needs to go ahead and do a rollout to capture the new information. So if you just edit a config map in production, your deployment's not going to know that you edited it. So the best practice is to just make a new config map, point your deployment to that, and let the old config map get garbage collected. And this hashing is just a convenience. Okay, finally, another use case I'm going to do is deploying from version control, which is certainly best practice. If I get the pager on any given day and I'm told you're in charge of the cluster today, the first thing I'm going to do is I'm going to try to determine, well, I sure hope this is coming from version control and not from somebody's workstation files, right? And second, I'm going to run kubectl diff, and I'm going to see if what's running in the cluster is actually represented in my directory in version control. So this is a way to deploy directly from version control. And then you can also specify down on the left here, there's a customization file which specifies it's going to get its base from a particular well-defined release, checksum to release in GitHub. So everything's accountable. You can go back and find out where everything came from. So are you keeping up with somebody else's configuration? Fine. You can fork it, make it your base. You can customize it, and then you can use git rebase to go ahead and merge in any changes they may have made. And you can do this at your own pace. You don't have to, if they change the base, if they change their representation of the resources they're using, you just capture it at your convenience and run it. And you're using Git and all the power of Git to allow you to manage that process. Yes, so Git, a Git repo with customizations describing your various variants is a really good place to start using Kubernetes. You'll get off to some really good best practices right off the bat. So now, this is the point in a talk when I'd normally do a demo. I am not going to demo this because it's like running sed. It's just not that interesting. It's like running make. It spits out a bunch of stuff. Go try the examples. There's a nice example in there of how you customize your breakfast, for example. Yeah, so I'll spare you that. I'm not done yet, 4 more slides. So I want to talk a little bit about the origins. There's 4 customized design goals. We wanted it to be composable, we wanted it to be Kubernetes style, we wanted it to be accountable, and we wanted it to be simple. These are all described in Brian Grant's declarative application management document that he's got out on the Kubernetes website. It's kind of a distillation of a decade of, actually many decades, if you count all the people that are involved, of experience running clusters. So composable, what does that mean? This gentleman, Doug McIlroy, he invented pipes, or he encouraged Ken Thompson, one of the creators of Unix, to add them to Unix. And it means using plain text, so you get YAML in, you get YAML out. You do one thing, you do it well, you're pipe friendly, and you say nothing, meaning you just put out to standard out what you need to put out there, and any errors or whatever you put to standard error. So if there's nothing in a customization file, you're going to send nothing to standard out. K8 style, that means the customization file itself will be Kubernetes YAML. There's nothing, we're not going to put anything special. We don't require anybody to add anything special to Kubernetes resources they're already using. We're going to use existing patch concepts that have been around in Kubernetes since the beginning, and we're going to target kubectl apply. Kubectl apply is the one major API you need to use, and you don't really need to use anything else. You don't need to use create, patch, delete. Apply is a good thing to use. Accountable. Accountable means we want to declare things. We want it to be declarative. It's not going to be, there's no execution involved. We want it to be GitOps by design. So we want it to, like I mentioned before, you want to be able to do a git diff against your cluster, and you want to be able to share bases via git. And fork rebasing is really important as well. Finally, we want it to be simple. So you can imagine that at Google, there's been many people who like to invent programming languages and like to invent different templating systems, and we've had all of that stuff internally for almost 2 decades, I guess. And it's kind of enough. We don't do that anymore. So this system has no templating in it. It has no new logic. There's no unintentional API. It just exposes the Kubernetes API, which is very well designed, very well thought out. There's a lot of community involvement in how the API should look, and we certainly don't want to obscure it by putting a layer over the top of it. And there's also no forced notion of a package or an application here. So to wrap up, the future, we're going to integrate this into kubectl. It's sort of where we wanted to be at the very beginning. So when you type kubectl apply -f in a directory name, it's going to look and see if there's a customization file there. We might call it apply.yaml, I'm not sure yet. But if there is, it'll go ahead and follow, it'll do the same, it'll be vendoring in customized code, so it'll follow the same execution path that customized build follows. And we're going to fix pruning at the same time, if you're familiar with all the problems associated with pruning. And then we're thinking about like throwing out a simple search engine like godoc.org that would allow you to find customizations or find resources and then customize them, because it's all about making things your own. So we're using it internally, and it's being built into another tool called KubeBuilder to help with deploying custom controllers. We want to use it for it's on our list of things to do, to use it to deploy Kubernetes in production, like internally run all the unit tests and stuff, help maintain Kubernetes development. And I know there's a lot of people in the community that are using it now too. They can share that whenever they get around to sharing it. But for what it's worth, with stars on GitHub, we seem to be doing pretty well. It's on the right trajectory. We got something like 1,300, I think, which is pretty good given we only started this about 6 months ago. And the other thing, it's kind of an easy thing to take up because there's no service here. It's just a command line. It's a fancy set, so it's not like anybody's work is at risk by adopting it. Yeah, I think the attraction is that it's really easy to manage the different variants. That's the trick, because many people, and also so managing different variants is one thing that people ask for a lot. Another thing that people have asked for is the ability to merge properties that are maintained by different parts of the organization. It's even as simple as I just want to run the service on my workstation as a developer, but I don't have the credentials I need that are used with my production instances, right? So things like passwords and databases and so forth. You just want to change that, And you don't want to maintain a copy of the entire thing, all of the configuration, because that's confusing and it'll get out of date and you have a merge problem all the time, right? So you just have the one little piece that you attach, that you use Kustomize to patch. So it's useful for that too. That's a lot of the feedback we've been getting from issues and so forth. Yeah, we've seen that a lot inside Google. There's templates. There's also schemes that use inheritance. And inheritances in particular is, so the templates, of course, right off the bat, you've got to learn all the logic associated with the templates and any bugs that you might have in your production configuration. You have to wonder, well, where did that come from? Is that from the templating system? And now anybody who's going to be involved in production has to understand that templating system and become an expert in it. And these things tend to get out of control because you add features, you add logic to them. We learned from, I don't know if anybody of this is going to date me, but Java server pages were once a thing where you merged Java in with HTML, in with JavaScript. So you could have one file that's got JavaScript, Java, HTML, CSS in it, and you have to try to make sense of that. And there's no IDEs, there's no unit testing framework for that stuff. So you want to try to we've learned that we want to keep things composable and split things out. That's why we all split all these things out now. And we use tools to help us develop these things. And templates aren't so amenable to using tools. Same thing with domain-specific languages, right? It's easy to make a domain-specific language. It's hard to realize that, well, in addition to the language, you're going to need to have, a rich set of libraries for people to use. You're going to have an integrated development environment to help people manage that. You're going to need some kind of testing framework. You're going to have to reinvent all this stuff. You're going to want to go to Stack Overflow and ask questions, and there's no content on there because nobody else uses this DSL. So my favorite language right now is Go. I can use that for a lot of things. I can use that for all of this stuff. So I don't really want to have another domain-specific language because I know the minute I do, we're going to have to add branching and loops to that thing, and then the gates are open. Patch is a fundamental thing to Kubernetes apply, right? So I think it has its roots in that. You can already send a patch in, right? And there's HTTP patch. So I think it has its roots in that. We recently added the ability to use JSON patching as well. But we don't want to have too much feature creep here because patching, JSON is briefer, but it's also a little unusual. The strategic merge patch, which we're using, those are the examples I showed there, they look just like resources that are partially defined. The pain with the strategic merge patch format, that patching format, is that to change the CPU, I have to have a full path going all the way down into the structure of the resource. So I have this kind of weird staircasing thing going on. It's okay. It's a little weird to read, but there's no logic there. So it's simple in that sense, and it's valid YAML. So yeah, I guess those are the advantages. There's history to it. It's valid YAML, and it's maybe verbose, but it's not complex. It's verbose, but not complex. Thank you. Yeah.